Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are going to dive deep into the divergence of a vector point function. Okay, so let's see what divergence in vector calculus. When we are talking about divergence in vector calculus, in this video, you will understand the concept of divergence of a vector point function, what it means, how to calculate it, and how it shows the behavior of vector fields like fluid flow or electric fields. Also, we'll explore the formula divergence vector f, divergence of vector f equals to, also denoted by del dot vector f. So we will also see this. Okay, so have you ever seen water spreading from a hose or air escaping from a balloon? You have blown a balloon completely. Okay, now the air is escaping out of the balloon. So what is happening there? The air is escaping out of the balloon, so it is some sort of a divergence, right? So what you are witnessing there is the divergence in action. So let's dive into what that means mathematically and why it matters. So what is divergence? Divergence is nothing but a scalar that tells us how much a vector field spreads out or converges at a point. Spreads out or converges at some point. Okay? It's like asking, is the field breathing out or sucking in at the spot? It's what? It is spreading out, or it is breathing out or sucking in at that particular spot. So mathematical definition you can see here. If the vector field f is equals to f1i plus f2j plus f3k, if this is equal to this, then the divergence of this vector field f can be written as, it is denoted by divergence of vector f is equals to del dot vector f, that is written as partial differentiation of x with respect to x, I plus partial differentiation with respect to y times j, plus partial differentiation of z into k, whole multiplied by f1i plus f2j plus f3k. This is what? Vector f. This is del, this is vector f. So now, here, I into I is what? 1, j into j is 1 and k into k is 1. So we are just multiplying dot product with the corresponding components, corresponding items. So dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Okay, this is a summation of dou f1 divided by dou x. So this gives us a scalar value. So note that the divergence of a vector point function is a scalar quantity. Okay, this is a scalar quantity. I'll give you a real-time example of air in balloons. Okay, so when a balloon deflates, that means air escapes in all directions, right? Air, do you have like one direction there? No, right? In all direction, whatever the direction it gets, space or whatever, it just deflates. It just gets out of that particular balloon. So the air's velocity field shows divergence because the field is expanding from a point, some point. So this is the balloon mouth. Consider from here. If the air is just coming out, of the balloon. So it is at this point. The air is diverging. From this point, the air is diverging from whatever the direction it is getting to the whatever direction it is getting. So that is one of the real-time example. I hope you like this explanation of the divergence of a vector point function. Do not forget to hit the bell icon, share, subscribe, like, comment, everything, whatever possible, okay, to support me so that I can help you out with all of your academic doubts. Thank you so much for watching. Love you all.